Okay, let's continue. So sometimes we need to solve a problem that has many variables or many constraints. So we know that if we want to give a mathematical formulation for a large program, we need to use summation for all and indexes. So we need to tell you in ample how to write that. So let's consider the second example. Suppose I have 3 products and 4 markets, and I have different production cost and retail price for each product at each market. I want to find a production and a sales plan that can maximize my profit. So the numbers here means for product 1, if I sell product 1 in market 1, I have production cost that is 20 per unit and the retail price is 30 per unit, etc. And for product 1, my capacity is 500. That means I can produce at most 500 of product 1. Okay, so when I see a problem description, I should first write down my mathematical formulation instead of start my ample programming. Just like what you do in writing a computer programs. You first design your program by writing algorithms, writing pseudocodes, or drawing flowcharts. You do the preparation before you start to write your programs. That's much more efficient. Here is the same thing. You write down your mathematical program before you do the real programming. So let's define our variables. I'm going to let xij to be the sales quantity of product I at market j, I from 1 to 3 and j from 1 to 4. For parameters, I'm going to denote the unit cost and the unit price of product I at market j as capital Cij and Pij. And then my capacity for product I is denoted as Ki. Then my mathematical model would be like this. I want to maximize my total profit if I sell anything by setting xij as a positive number. My unit profit or unit margin would be Pij minus Cij. I repeat that for the 12 possibilities. I have several constraints. First, I have capacity constraints. So for each product, the total amount I sell in all the markets cannot be greater than the amount I may produce. And I have non-negativity constraints. Okay, so that's the formulation. That's easy. If we want to solve these kind of larger and larger problems, we want to make our ample programs flexible and extendable. That means we should start to decouple the data from a model. Okay, so that's why we want a model file and a data file, so that it will be easier for us to do the decoupling and to expand our model to more general situations. The model will contain just a conceptual model, and the data should contain those instance parameters. And that would be good if today you have a problem, then you have a model. But then you may have different parameters in different environments. Then you just need to have different data files. That allows you to reuse your model file. Okay, so in any case, they should both be stored as plain text files, and the extension names again does not matter. So in the following example, I'm going to call them eg2.mod and eg2.dad and store them in the program folder again. So now let's look at my model file first. I now want to define some parameters. So I have param as my parameter keyword. If I do this, then I'm giving names to the parameters. For their values, I define them in my data file. Okay, so I have P as my number of product, M as my number of markets, and I have capacity cost and the price. For capacity, it is a vector. So when I do this, when I use these curly brackets to do the definition, that means I am declaring a capacity vector where I use I as the index and I have 1, 2, 3, 4, 5, blah blah blah, up to p different values for capacity. For cost and the price, they are metrics because they have two indexes. They are two-dimensional values. Okay, then in that case, the syntax is that I have I as the first dimension, j as the second dimension, and for products, I have 1 to p, and for market, I have 1 to m. Okay, and I separate them with a comma. Then the remaining things are defining the model. I have variables, and now I also have a two-dimensional variable. So the way to define it is just like defining those matrices here. But now x is a variable, and later I'm going to access these variables through the indexes. And then I want to maximize profit, and my profit would be the sum over I and j, such that for each I and j, I calculate this particular value. Okay, this part is your Pij minus Cij times your Xij, and the sum of them should be expressed with this sum notation. Okay, so this is where you put the indexes for your sum, and here you use the square bracket with commas to denote your indexes of accessing those price, cost, or variables. And then we have two sets of constraints. If I have a constraint that should be satisfied for all the products, then I do use this notation. Before the comma, I define product capacity 1, product capacity 2, blah blah blah. For each product, I have a separate constraint. And for that, for each product I, the sum over all the market, I calculate the sum of Xij. And then this is my total product that I produced should be less than or equal to the capacity of that particular product. And I also have non-negativity constraints, and again, I have a lot of them, and for each of them, my value should be non-negative. Regarding my data file, I just need to, again, know the syntax. If I want to define the value for a parameter, for a scalar, then just write something like this. Use comma equal to assign a value to your p, to your m. For a vector, then we define the values like this. We use comma equal, and then index 1, 500, 2, 600, and 3, 400. So that means we give values to capacity while telling capacity what are the indexes of those values. And finally is the syntax for defining a matrix. It's like this. So you of course do not need to format your code like this, but this will make your program more easily to be read. So this is two-dimensional parameter. So obviously this is saying that for cost 1, the value is 20. For cost 1, 2, the value is 40, etc. You first define 4 columns, and then you have comma equal. And then for each row, you first indicate the index, and then you indicate the values, etc. Okay? For price is the same thing. So it's a little bit tedious, but the rule is unambiguous. Okay? Be aware of those comma equals, semicolon, and column at any time that you need to use them. Then you will be okay. Array and matrix length, of course, must be consistent with their limits. Otherwise, when you load the model and the data file, you see some errors. Now, if I try to solve the problem, again, I reset and then load my model file, and then use data to load my data file, and then I solve. Now I only need to display x, then all the values of x will be displayed at the same time. I would see a screen like this. This tells me that, oh, okay, x11 is 0, x13 is 500, etc. Okay, so that's how we solve the second example. Okay, so finally we have some remarks. First, the default solver in AMPLE is the minus solver. This would be good if we want to solve nonlinear programs, but now we are still at solving the linear programming stage. So please use Cplex, which is better, which is more powerful for solving linear programs and integer programs that we will introduce later. So please use Cplex as the solver for solving linear or integer programs. Okay, and then AMPLE is case sensitive, so you're going to be aware of that when you write your programs. Capital A and small a are different things. You may want to try some AMPLE instructions like show, expand at home to see how they may help you. If you want to exit the AMPLE environment, use exit. And finally, on the official website, there is an official AMPLE textbook that is free, and you may download the PDF just at any time you like. There are a lot of more advanced techniques, like you may define sets instead of indexes. You may use other kinds of operators that may make your program even more powerful. But if you only use the technique we introduce in this video, you will be okay for most of the programs that we require you to write. And for further techniques, please teach yourself. Okay, that's the end of the introduction of AMPLE. Thank you.